All right, let's look at something that confuses a lot of people the moment they start working with generators in Python. Everything looks fine at first, and then suddenly your code just stops working without throwing any error. So imagine this. You have a stream of data coming in, maybe temperature readings from a sensor, maybe live values from an API. And since this data is coming one value at a time, instead of storing everything in a list, you decide to use a generator, which is the correct thing to do. So the first thing we do is create a generator that gives us these temperature readings. Now, below that, we write a simple for loop. And inside this loop, we print something like processing reading, along with the value. And when we run the program, everything works perfectly. All the readings print one by one, no issues at all. Now, let's say we want to use this same data again. Maybe the first loop is doing some actual processing, and after that, we also want to log the same readings for debugging or monitoring. So right after that first loop, we write another for loop, again looping over the same generator, and this time we print something like logging reading. Now, when we run the program again, something strange happens. The first loop runs fine, but the second loop prints absolutely nothing. No error, no warning, just nothing. And this is where generators trip people up. What's happening here is that generators can only be consumed once. As soon as the first loop finishes, the generator is completely exhausted. There's no data left inside it. So when Python reaches the second loop, there's simply nothing to iterate over. Now, one thing we could do here is convert the generator into a list. That way, the data is stored, and we can loop over it as many times as we want. And yes, that would solve the problem, but that also creates a new one. If this data is large, or worse, if it's a continuous stream, storing everything in memory is not a good idea. We lose the entire benefit of using a generator in the first place. So now the real question becomes, how do we use the same generator data in multiple places without exhausting it and without storing everything in memory? This is where Python gives us a much better solution. Instead of consuming the generator directly, Python allows us to split a single generator into multiple independent iterators. And for this, we can use a function called t from the itertools module. So now what we'll do is this. We'll keep our generator exactly the same, no changes there. Then we'll create two separate iterators from it. One iterator will be used for processing the readings, and the other one will be used for logging. To do that, we use the t function. Inside t, we first pass our readings generator, and then we pass the number 2, which simply means we want two independent iterators from the same data stream. T then gives us back two iterators, and we store them in two variables, one called process stream and the other called log stream. Now we loop over the process stream, and for each value we print processing reading. After that loop finishes, we loop over the log stream, and this time we print logging reading. And now when we run the program, both loops print all the readings correctly. No data is lost, the generator isn't exhausted, and we didn't convert anything into a list. So what T is doing internally is handling the buffering for us, just enough so that both iterators can safely read from the same original generator without interfering with each other. And this is exactly why T is so useful. Whenever you have a single stream of data and you need to use it in multiple places, processing, logging, monitoring, analytics, T lets you do that cleanly, efficiently, and without wasting memory. So the next time you're working with generators and something mysteriously stops printing, remember this: generators can only be consumed once. And if you need that data in more than one place, T is the right tool for the job.